We're going to build a port scanner in about 100. Will it replace Nmap? No. But when you build it yourself, you stop using Nmap as a black box. You understand exactly what's happening every time you run nmap-sv. No libraries, no third-party packages, just Python's socket module. Let's go.
Disclaimer. My lab, my hardware, my network. Doing this on unauthorized systems is illegal. Educational purposes only.
Before we write anything, let's understand the mechanic. When Nmap runs a TCP connect scan, nmap-st, here's what happens. Your machine sends a swen packet to the target port. If the port is open, the target responds with swen-asec. Your OS completes the handshake with asec. That's the TCP three-way handshake. Connection established. If the port is closed, the target responds with rest, reset. Connection refused, port closed. If there's no response at all, the port is filtered, probably firewalled. A connect scan completes the full handshake. That's what Python socket can do without any special privileges. A SYN scan, Nmap's default, only sends the SYN and reads the reply, then resets immediately. That requires raw sockets and root access. We're doing a connect scan, same result, no root required. Create a new file, port_scanner.py. Here are all our imports. Only standard library, no pip install needed. Socket, the core. Every scan request goes through this. Concurrent.futures, threading. This is what makes it fast. Arrogance, professional CLI. Datetime, timestamps in our output. Look at how Nmap handles port input. Nmap-p22 arrow 1 port. Nmap-p1 to 1000 arrow range. Nmap-p22, 80, 443 arrow list. Nmap-p22, 80, 100 to 200 arrow mixed. We support all of these. The logic, split on comma first. For each part, if it contains a hyphen, it's a range. Split, open parenthesis, quote-quote, comma, 1, close parenthesis. The 1 means split only on the first hyphen. This handles ports above 9 correctly. Common_ports is the default when no -p flag is given. These are the ports you'd scan in a real engagement first. SSH, HTTP, HTTPS, SMB, RDP, MySQL, PostgreSQL, Redis. The ones that are almost always interesting. GetServbyPort looks up port numbers in the OS service database. Port 22, SSH. Port 80, HTTP. Port 3306, MySQL. The second argument, TCP, tells it which protocol. If the port isn't in the database, it raises we return unknown. This is how Nmap knows what service is likely running. We're using the exact same OS lookup. Grab_banner is called only if -b is passed. Some services send data immediately on connect. We read up to 1024 bytes, decode as UTF-8 with error replacement. The decode errors equals replace means non-UTF-8 bytes become question mark, so binary data doesn't crash us. Scan_port. This is the most important function. Everything else supports this. Socket.af_inet IPv4. Socket.sock_stram TCP, not UDP. Now, connect parens versus connect_ex parens. This is important. Socket.connect raises an exception if the connection fails. Socket.connect_ex returns an error code instead. 0 means success, port is open. Anything else, port is closed or filtered. Why does this matter? If we used connect, we'd need a try/except around every port. With connect_ex, the logic is clean. If result equals 0, open. Set timeout. This is what prevents hanging. Default is 1 second. After that, move on. The -t flag lets the user adjust this. If the port is open and banner grab is enabled, we call grab banner while the socket is still connected. Then we close it. Resolve_host. Get host by name does DNS resolution. Pass scanme.nmap.org, you get back 45.33.32.156. Pass an IP directly, it returns the IP unchanged. The exception socket.guy error. That's the specific exception for DNS failures. If resolution fails, we exit cleanly, no stack trace. This means our scanner works with both IPs and host names, just like Nmap. Save_results. Simple. Open a file, write a header, then 1 line per open port. Notice we only call this function at the very end, after the scan is complete. We also only call it at all if the user passed -o. No -o flag, nothing is written. Results stay in the terminal only. .h is uppercase, because lowercase h is reserved for help. Try adding h without defining it. Argparse adds it automatically. P defaults to common, the string, not a number. That's the signal to use our common_ports list. T and T, I keep these consistent with Nmap's conventions. Nmap uses -t for timing templates. We use it for timeout. Close enough. -b is banner grab. Action equals quote store_true quote. Present means true, absent means false. 100 threads as default is aggressive, but works well on a local network. For remote targets over the internet, drop to 20 or 50. Alright, before I write the rest of the code, let me test what we have so far. I'll open a terminal and run python port_scanner.py-h. Nothing happened. Let me check the code. I see the problem. I defined main, but I never called it. At the very bottom of the file, I need this. Let me add that now. Run it again. Python port_scanner.py-h. There we go. Full help output. All our flags. -h, -p, -t, -t, -b, -v, -o. The examples at the bottom from our epilogue. Good. Architect is working. Now let's write the rest. The code is done. Let me test it against my own machine. First, find my IP address, ipconfig. Let's scan it. Oh, an error. Let me read it. Name error, name lin is not defined. I wrote lin instead of len. Let me fix that. Run it again. Let me check the help again to see all the options we built. Python port_scanner.py-h. Good. Now let's test the other flags. Port range. Python port_scanner.py-h. Scanning 1000 ports. Takes a few seconds with threading. Results come in as threads finish, not in order. That's normal. Now let's save the output. Python port_scanner.py-h -p1 to 1000 -o-results.txt. Results saved to results.txt. Let me open the file. There's our report header with target, IP, timestamp, and every open port on its own line. I also tested -b for banner grabbing and -v for verbose mode. Both work as expected. The scanner is fully functional. The tool works. But when you run it, it goes straight into scanning. No visual identity. Nothing that says, this is my tool. Let me fix that with two functions, print_logo and print_scan_info. First, the logo. I'll copy it from my GitHub. Link is in the description. It's ASCII art, but it makes the tool look like a real security tool. Notice, print_logo, open parenthesis, close parenthesis, has no parameters. That means I can call it before Archivo runs. So even if you run python port_scanner.py with no arguments, the logo appears. Then APK shows its error, much cleaner than a blank screen. The second function handles the scan-specific info. This one gets the scan parameters after argit has parsed the arguments. In main, I call printLogi as the very first line, before anything else. Then print scan info after the host is resolved and ports are parsed. Let me test it. Run with no arguments. Python portscanner.py. Logo appears, then the rsbar op runner. Clean. .py-h, logo, then help text. And a real scan. Logo, then the scan info block, then results. That's it. The tool now has a visual identity. That's a working port scanner. Pure Python. Just sockets. No Nmap installed. No third-party libraries. Does it replace Nmap? No. Nmap does UDP scanning, OS fingerprinting, NSE scripts, and 100 other things. But the core mechanic, TCP connect scan, that's exactly what we built. Now when you run nmap-st, you know precisely what's happening. The code is in the description, GitHub link below. Next video in the series, we look at network packet analysis in Python. Sniffing packets without Wireshark, using Scapy. Subscribe if you want to see that. See you in the next one.